Okay, so welcome, and I'm going to talk about problem set one. It's my iPad is not very big, but I try to put the question like my notes here at the same time. So it's better for you to open the PDF file on your end as well and to see the questions clearly. So let's get started. First is about question one in problem set one. It's about perpetuity. So at the beginning, let's see what does the question, the information, what is the information given at the top of the question. We know that the expected net operating income, which is NOI, next year is 150K. So from now on, let's use time 0 as today and time year as next year and 2 as 2 years later, just for notation. So our NOI 1 is 150K. And the next sentence is very important. It says the discount rate that reflects the riskiness of the investment is 10%. So it means the R, quote, market, or the fire R is 10%. So this is very important because when I'm grading the homeworks, it seems like many of you mess up with what is R, the market R, and what is the IRR, like the implied rate from the investment. So these are very different. The market R is the R, the unique one that is given by the market. And it's like the fire value that evaluates the riskiness of the investment. So let's continue. I will explain more about what it is in the later question. So in the first small question, this is Q1. In the first one, assume the NOI is perpetuity. What is the PV? So the PV, this one is very easy. Most of you get it right. PV is just using the perpetuity formula, which is we want to get the present value at time 0 equals to next period NOI divided by the cap rate, or NOI divided by R minus G. So in this question, we know that NOI is 150K, R is 10%, and there's no growth. So growth is 0%. It gives you 1.5 million. And then it asks what is the cap rate. So there are two ways you can get this. The first one is just to use the formula above. It's just NOI 1 divided by PV 0. PV 0 is the one you just got. So you will get 10%. Or what you can do is following the formula, because if you look at this second equation, you know that cap rate also equals to R minus G. So it's just 10%. Both ways works. This is an easy one. But one thing I want to emphasize here is the cap rate. This definition, oh, sorry, it cannot be seen clearly. So the cap rate definition is assuming perpetuity. So in all of our materials, you'll never see cap rate appears in any other cash flow calculation, present value of other cash flows like annuity, those kind of things. So in other words, only when we are working with the perpetuity, we have this formula the formula that incorporates cap rate, which equals to the discount rate R minus the growth rate. So then let's go to small question 2. Suppose you bought the building at the value you calculated. This one means you buy it. Payment is 1.5 million from the last question. And what will be your IRR? So here is about the definition of IRR. I talked about this in my in the Q&A before the exam, before the homework, but I still want to emphasize there are two things. If you get cash flow and discount rate, or maybe growth, and want to get present value, you are evaluating the value of the investment. But if you get cash flow and the payment or present value, and you want to find IRR, this one means you're evaluating what is the return that you get on the investment. So the logics are very different. That's why in this question, it's asking you to get IRR, not like R, because R, discount rate, in this question, most of the time means the market one. So you just find it's given at the top of the question. So let's get back to this question. What's your IRR? By asking IRR, it means you get the payment or the present value you assume it is, and the cash flow you get. Cash flow is just the perpetuity. So from the information you have, you get payment equals to NOI 1 divided by IRR minus G. So here it's not R anymore, it's IRR, because this one is unknown and this is what you want to get. Equals to 150K divided by RRR minus 0. And then you will get IRR equals to 10%, which is same as the market one, the 10% that is given at the top. So it has a reason, because when you get the market, when you get the present value 1.5 million, you use the market R to get it. So if you back out using the present value 1.5 million, you should have the exact same R, because it's a unique solution. You cannot get multiple R's from it. It means you're paying the fair value to the for the investment, and it means you are earning a fair rate from the market. Your earning IRR is same as the market one. This one will be changed later in the following questions, like when you have to pay 1.7 million, or when you want to make it worth 2.2 million, whatever. It will change your implied return, which gonna be different from the market. So let me detour a little bit. When you evaluate an investment, there are two ways by comparing investment. So for example, you have many investment opportunities, and you have like many projects on the internet, and you're looking at two ways to compare it. The first one is just by present value. So in other words, following this, the first bullet point here, you know the cash flow, and you know the fair discount rate of this project. You want to know how much it's worth today, because all the cash flows are occurring in the future. Then if you want to evaluate, you can get, if you can get the present value for all the different projects, you can compare, or which one has better present value, which one worth more at today. So you're gonna know, oh, okay, which project is better for you. Another way to compare is by compare return. So suppose one project gives you 10%, the other gives you 20%, then which one is better? Then of course it's the 20% one. So to compare return, you're basically comparing IRR. So suppose you have like $100 that you want to investment in either of like many projects, and they will give you some IRR, give you some cash flow, and you want to know, like, by investing $100, how much return you can get. Then you know the payments today, or the value you have in mind today. and the cash flow that is occurring in the future, you can back out the IRR using, here is the perpetuity because the project is a perpetuity. And after you back out IRR between different projects, you can compare the IRR and make your own investment decision. So this detour is related to the following questions. When the IRR is different from the market one, it's most of the time driven by your current valuation of the project. Let's see more details. In small question 3, it says the building is offered for sale at 1.7 million. In other words, you pay 1.7 million to this building. Then what is the cap rate? Cap rate, following the formula we covered in class, the payment equals to the NOI, next period, divided by the cap rate, which gives you cap rate equals to 8.82%. So you can see this cap rate is lower than the IRR, than the cap rate we got earlier, because the return you get is lower because you pay more than 1.5 million. And what is the NPV? NPV equals to the value, present value of the project minus your investment or your payment. Basically, it's just saying how much it's worth minus how much you pay to get the property. So this will be 1.5 million because it's not changed at the beginning. So because you used the market fire discount rate to get the fire present value of this property, and you pay for 1.7 million because it's offered at this price. It will be minus 200K. So it's a negative project because you pay more than it's worth, more than the fair value. Following the third question, the fourth one asks you, what is the IRR? So this one is related to my detour earlier. The IRR is not known now. It is unknown now because you have your payment and you have your cash flow, and your goal is to back out the IRR. To get it, still, because we have a perpetuity formula, the perpetuity cash flow, what we had is, what we need to do is 1.7 million, which is the present value, equals to next period NOI minus IRR minus growth. Growth is still 0. Then what you get is IRR equals to 1.150K divided by 1.7 million equals to 8.82. So you can see this IRR is the same as the cap rate we got from question 3. It's because we don't have growth. And because in both to get cap rate and to get IRR, we used basically the same information and the same formula. So the only difference is the growth rate. And another thing I want to emphasize here, because I found like many people made some mistake when I'm grading. Another detour. IRR is not cap rate. So loosely speaking, IRR includes both cap rate and the growth rate, because cap rate equals to IRR minus G, minus growth. It's all because here G is 0, so they're the same. But if you just equivalently switch them, it's not gonna be right, because it's totally different concepts. And IRR itself can show up in any cash flow, like annuity or lumpy cash flow, etc. But cap rate, as I said earlier, cap rate is assuming perpetuity. So this is exantic assumption. Only within the perpetuity you will see the concept of cap rate exists. Okay, so we finished question 4, and let's go for the 5 and 6. So 5 and 6 is more challenging because you know the formula, but you don't know some of you like mess up which number to plug in. That's the problem. That's why I spent many time like tell you what's the difference between PV and IRR, what does it mean? So let's see question 5 in question 1. So it says the seller is unwilling to negotiate the price down. So it's like you really like the property. Of course you want to pay cheap, but the seller doesn't want, and you still want to buy the property. So you will just buy it as it is, as the price is given. But you want your property to worth more. So what you can do, you cannot change the payment. The thing you can do is to change the cash flow that will generate. So the more cash flow it generates, the more valuable your property will be after you pay for the fixed cost at the beginning. Then this question is assuming you do some fancy improvement. Maybe you like put some fancy decorations or you give other facilities. It will make your net NOI or the net cash flow grow in the future, like forever, because we're still assuming perpetuity. Rather than like question 1 to 4, here you have a growth, but you don't know what it is. And this is what the question is asking. So suppose you pay for 1.7 million. You really want the value of the property is 1.7 million, so that you don't waste your money on investing. So what do? NOI you cannot change. It's just the 150K, and you want it to grow so that it's worth. Then when I'm saying it worth, it means you have to use the fire discount rate from the market, because because again the IRR is coming from you assuming like you get some present value as it is at the beginning, and then you back it out. But here you want to make the okay, let me write it in this way. The present value is still just a PV, and you want to make the fire value of it equals to your payment. So this one, the fair value of the property is NOI divided by the market R minus G. G is what you want to find, and it is 150K divided by 10% minus G. And what you want is you want this whole thing to be the same as your investment, which is 1.7 million. Then you can back out the growth, which is 1.18%. So in other words, you do some good improvement to your property so that you try to get your future cash flow grow at this rate. Then the present value, fair present value of this property will be the same as your payment. Then it will become a fair deal for you. So some of you like might mess up just to plug in some 1.5 or some other numbers here, but it's not your payment, so it's not right. And the next question, does the transaction increase your net wealth? It's a little bit tricky because it should not by default. Like when in the previous question, it says how to make the transaction worthwhile. Worthwhile means the NPV, like the value of this project minus your investment is 0. So it already break even your payment or the value you earn. So the NPV should just be 0, which means it doesn't increase your wealth. Some of you in the calculation did some cute, very cute thing. You do like, oh, because we got a growth rate, so we know the PV is just the NOI 1 minus divided by R minus G, which is 150K divided by 10% minus 1.18%, and it will become like a 1.7 million and plus some like $600 or something. This is this is like higher than 101.7 million. So it's a good deal. So it's making money. This is wrong because you got this growth rate from this formula, and it's not a wrong, it's not a like 1.18%, it's not a very precise number. So ex ante, you're assuming NPV is zero. It's not a positive NPV project. You cannot say, oh, because I plug in a less precise number and I make it positive. So it is not gonna happen. So that's why, like in some of your comments, you can see I say check the calculation precision, because it's by default ex ante is not gonna increase your wealth. So that's why I say it's a little bit tricky problem, because it's already answered in the question. So the last one is, what is the IRR of the transaction if you manage to increase your growth so that the NPV equals to zero? This is also very tricky, because all you need to do is, again, back out the IRR. The payment is 1.7 million. Oh, sorry. The payment is 1.7 million. It equals to 150K divided by RRR minus G. So in other words, the G is the one you already got, 1.18%. Then what you get is IRR should be exactly the same as what you used here. Why? Because basically the formula here and the formula here, the information you plug in are basically exactly the same. So if you get IRR other than 10%, it should be a problem, because you plug in the wrong present value, which is not 1.7 million or whatever. So it should be the same, because you used the market discount rate to calculate the present value. Okay. So let's see the last question in this question. What is the the growth rate that will increase your net wealth by 500K? So in other words, like following the previous question, you bought the property at 1.7 million, and you really want it to worth more because you want to make yourself wealthier, as we explained in the previous question. By paying just the 1.7 million, it means you're not making any profits from this project. So you want to make a profit of 500K, which means you have to make the present value of the whole project 500K more expensive. So 500K means 0.5 million. And plus the present value of the project, which is 1.7 million, is equals 2.2 million. So what you want to do is you want to try to find a growth rate that will make the project worth 2.2 million. So how do you do that? Still, when I say you want it worth 2.2 million, it means you should use the market discount rate, because that's the fair value. So 2.2 million equals to NOI next period divided by R minus G. Still, G is the goal that you'll try to find. 150K divided by 10% minus G. So from here, we can get G is 3.18%. This is higher than the 1.18% we got from previous question, because it makes sense, because you want your current your profit to worth more than this number 1.7 million we used earlier. So you need a higher growth rate, meaning your future cash flow should be much higher than now, than the previous version. So your growth rate is 3.18%. Then he asked, what is the IRR of the transaction? This is a little bit tricky. So 2.2 million is not the payment you pay for the property. 2.2 million is your ideal value of this project. So again, to get IRR, you really need to put the the payment, the price you pay on the left-hand side, which following the previous question is 1.7 million, is the one you pay for the project, and is equals to IRR minus G. And G we already got here, which is 3.18%. And this is 150K. So altogether, you get IRR equals to 12%. So this IRR is higher than the market one because you manage by making the growth rate higher, you manage to make your project worth more, which is at 2.2 million. But you're only paying 1.7 million, which means you're earning a higher return for paying low. So it should be higher than the market one. Another detour. I see many of you are using this kind of formula for getting IRR. I think maybe you did diligent work searching on Google and try to figure out what is IRR. But again, IRR itself is a concept that goes with the pattern of your cash flow. So if you use this formula, it means it means a lumpy cash flow that only occurs at time one. It doesn't have any future cash flows occurred, which makes sense because you are basically discounting one period of cash flow to today. It's totally wrong because in this question, we are always assuming a perpetuity. So to get perpetuity, should always be NOI divided by IR minus G. This is the one that you should use for all the calculation. Okay, I think that's question one. Does anyone have question? Cool. So let's continue. Let's take a look at question two. Okay, on top of everything. So before the questions, the question two gives you some information. First is your NOI next period is 100K. And it will remain the same, which means G equals to 0. There's no growth rate. And the discount rate reflects the riskiness of the investment, which is the FIRE discount rate, R equals to 9%. So still, first one is very easy using the perpetuity we talked a lot about, which is just a present value at time 0 equals to R minus G, which is 100K divided by 9%. It equals to 1.11 million. This is easy, I think. And for the second one, a little bit tricky. So suppose the property is you and your friends are gonna buy the property together because maybe you don't have enough money or you're good buddy with your friend. So you're gonna split the partnership into half and half, which means both of you will pay half of the price. And we just got the price, the FIRE price of the property from question one, which is 1.11 million. Then what you and your friend pay should be equal. $1.11 million divided by 2. So it has too many 5 in that. So I just let's just use half of the 1.11 million. And he says, she says she's gonna collect the, so, okay. So if you and your friend buy something together, and how do you make it fire? One simplest way is just along the time, whatever the income is, whatever the NOI is, you're just split by half. This guarantees that you're sharing it in a fair way. But your friend considering some other things, she says, oh, how about this? I will just collect the cash flow for first several years, and then you collect all the cash flows in the future. And the goal is to find how many years she wants to collect in this question, in her suggestion. So there are two ways to do this. First one is think about what your friend pay and what your friend get. Basically, what your friend get is oh, sorry. This is infinite. So what your friend gets is cash flow for this region from year 1 to year X. And what you get will be from year X plus 1 to the future. So your friend gets an annuity because the NOI does not grow at all. It's a without growth annuity. And your friend, the present value of your friend's part, plug in the annuity formula, is just a 100. Let me write down the annuity formula first. It's NOI 1 divided by R multiplied by 1 minus 1 over 1 plus R to the power of T. So NOI is 100K, R is 9%, and 1 minus 1 over 1 plus, 9% to the power of X, which is because T, capital T here is basically the X she's getting. And to make it a fair deal, the present value should be the same as the payment, which equals to 1.11 million divided by 2. So this is the one you're looking for. 1.11 million divided by 2 equals to this a little bit ugly thing. So what you get is X. You can back out X using play with Excel or use just the math using the log function. And what you should get is X equals to 8.04. And some of you reported me 9 years. It's fine. I didn't deduct any point, but actually in the question, it clearly says if X is not a round number, round it to the closest integer. So it should be 8 years. That's the first way to say it, to do this. The second way is from your perspective. Again, what you get is you basically get, you basically get a perpetuity that starts from X plus 1. And it's a perpetuity without growth. So to make it fair, you need to make the present value equals to the discounted cash flows in the future. So what you get is, first, you get a perpetuity, and the present value of the perpetuity at year X equals to NOI X plus 1 divided by R, which is 100K divided by 9%. There's no growth. So one thing that you need to take into consideration is this present value of perpetuity is at year X, not X1, X plus 1. Then you need to discount it back because your payment occurs at time 0. And the present value of this perpetuity at time 0 is present value at X divided by 1 plus R to the power of x, because you need to discount it back by x years. Then to make the fire deal, this part should be equal to your payment, which is 1.11 million divided by 2. And this one is 100K divided by 9%, divided by 1 plus 9% to the power of x. And these two things should be equal. You will get like almost the same number out of it. So the result is the same. You still need 8 years for your friend. That's question 2. And after you get the x, starting from question 3, he asked, oh, after x years, which is, let's just say x equal to 8. So after 8 years, you want to sell it, and nothing changes in the perpetuity, which means the NOI will still be 100K, and it will last forever. So it's still perpetuity with NOI 100K without any growth. Then what is the market value of the property in year X? So some of you do the first step, right? I mean, do what the question asks exactly, but you discount back to today. But the question is asking what is the value in year X, which means at the end of year X, how much it values. It's basically what I did here. PVX equal to NOI X plus 1 divided by R. So PVX is just a 100K divided by 9%. And it's still 1.11 million. You don't need to discount it back to today because he's not asking about the present value at today, it's asking about the value in year X. So it's very simple actually, as same answer as the first question. Then the question is, do you need to share the proceeds of the sale with your friends? The question is no. Why? Because intuitively think about this. At time 0, you and your friend both pay half price or half value of the property. Why after several years you're gonna share the profits or share anything with your friend? It's not gonna be the case because you already pay the fair price and you get X using a fair evaluation method. So you don't need to share. And the thing is, at the time 0, at the time 0 you'll pay the same payment, but your friend collects much near cash flows that compared to time 0 because she will collect the first 8 years cash flow, and you will collect cash flow starting from far future. And it feels like in year X, it's 1.1 million, it doubles your payment, and it feels like not good and you need to share it with your friend. But no, because she is collecting near future cash flows, which has more value because the longer you wait, the lower the value of your cash flow will be. So that's the first thing, because of the discount factor. So she's actually collecting much more valuable cash flows than you. And the second thing is, although in this question, we are assuming it's a very safe, stable perpetuity, but in the real world, you never know what's gonna happen in the far future. So you're actually facing much more risk than your friend. So you deserve to get some a cash flow that looks very high in year X because it's in far future and you face time value and the risk. So plus you paid for the fair price at time 0. So you don't have to share any of your proceeds with your friend. Okay, not share. Last question. Suppose you sell the property and keep the proceeds to yourself. What is your IRR? And what is your friend's IRR? So still, IRR is coming from the perpetuity and your payment. For you, your payment is 1.11 million divided by 2. And you will receive a perpetuity starting from year 8. So the value of your your perpetuity will be still 2 steps as I explained first. You have to first calculate the PVX, which is PV8. It comes from 100K divided by R. Okay, let's call this IRR because your goal is to get IRR, the R out of the equation, and divided by 8 because you need to discount it back to today. Yeah, and this part is simply, oh, sorry. Sorry. Okay, so okay. This part should be 100K divided by R, which is the market R. This part should be 1.11 million. The reason is because you already decide to sell it right away after you get the property. So the value of it is given from question 3. So it's just a 1.11 million. And the IRR means during your holding period, what is the implied return you get? So this part is the one that is changing, that is implied. This part is not because the fair value is already known at year 8. Then apply the formula, you will get IRR equals to 9%. It's exactly the same as market one. It's all because you are not making any improvement. You're not paying extra money. You're not doing anything. You're always working with the market price or market cash flow or market riskiness. So your return should be exactly the same as the market one, which is 9%. And the friend, what is the friend's return? So again, your friend pays 1.11 million divided by 2. And so the annuity part contains 2 parts. This is the perpetuity part, which is still given. And this is actually the IRR you're looking for. Still, for your friend, it's all because she is collecting the first 9 years, and this is the part that is within her holding period. So she wants to back out the return on her holding period. As a result, she uses the IRR. She backs out the IRR from this part rather than this annuity, rather than this perpetuity part. So you should get exactly the same return because you and your friend are basically paying the fair value, split the fair value evenly. You both pay the same thing, and you get the same fair value of future cash flows at today. As a result, you should have the same return. If you get higher return than your friend, it's not a fair game between you two. So to make everything clear, make everything fair, the present value and the return should all be just the same. And during the grading, I see still some of you use the lumpy cash flow formula, which is definitely wrong. And some of you just give me some results without any explanations. That's also not good. Some of you say, oh, I did it on Excel, but by doing Excel, some of you get your IRR is only 8% and friend IRR is 9%. Apparently your friend IRR you get is right, but in Excel, for your part, you pay at time 0 minus 1.11 million divided by 2, and from time 1 to time 8, it's all 0. And from time 9, there's 1.11 million. This is what I see from the spreadsheet. that some of you report to me, and you apply ARR formula, you get 8%. This is wrong because this 1.11 million should be at year 8. Still, the 1.11 million is from 100K divided by R, which is 9% divided by 9%. This 100K starts from year 9, but it means this whole value is at year 8. So you should not put this like perpetuity value at year 9 and do the IRR calculation. You should put the time right. So put it at year 8. And then if you apply the IRR formula, you're gonna get the right one. Okay. This is the question 2. Do you have any questions? Cool. So question 3. Before everything, let's see just a new building, and it takes 3 years to complete the project, and after 3 years will be, it will start to accumulate collect rent, but it's relatively low, only 50K per year, and then it will become 100K with growth 1%. So there is there is a NOI which is 50K. Let's call it NOI subscript 1. And another NOI subscript 2 is 100K. So this subscript, sorry, does not mean year. Year, let's put it here, put it on the subscript. So, and the growth is, in the perpetuity part, growth is 1%. So there might be some confusions about the question, but let me state the cash flow I'm looking for when I'm grading. So in this question, the real cash flow or the timing of the cash flow is like this. You pay something at today, and you will get 50K from year 3, year 4 to year 5. And you will start to get 100K from year 6, and year 7 is 100K times 1 plus G, and year 8 is 100K plus times 1 plus G to the power of 2, and it will grow forever. So this part is a 3-year annuity, and this part will be a perpetuity starting in year 6. So this is related to the 4th question in this big question. So I see some of you are doing perfect job using the formula, but you mess up, some of you mess up with the timing of the cash flow. So it's very important to get the precise answer to make sure your incurring cash flow is at exactly the same, the right time. Okay, before that, let's start from question 1. What is the discount rate you should apply? Oh, sorry, I left one sentence. There it says, similar mature buildings are offered in the market at a cap rate of 6%. Similar building means it's market, it's fire discount rate. And in this building's NOI is growing at 1%, which is same as before. So the fire discount rate will be cap rate plus growth rate equals to 6% plus 1% equals to 7%. It's very easy. And because it's not asking you for IRR, it's asking for the discount rate, which means the fair market one, and you use the market cap rate and market growth rate, it's 7%. So in question 2, assuming market will not change going forward, will not change. And what will be the fair value of the property in year 6? It's asking you to calculate PV. Is that year 6? Oh, I'm sorry. Did I? So this question is actually asking you PV5, but I'm not sure if it's like corrected in the file. So it means like he is asking you to evaluate the perpetuity that starts in year 6, and see how much it worth at year 5, because perpetuity by default, if your cash flow starts at year 6, you're calculating the value of the property. So this might be a little confused. So the right interpretation is, suppose you get all the cash flow starting from year 6 here. Suppose you get all the cash flow starting from year 6. What is the fair value of that? If you want to pay for that, then it should be 100K divided by 1R minus G. So it's 100K divided by 6% equals to 1.667 million. So I think as long as you're like on the track of you doing perpetuity, you should not be deducted many points. Some of you might discount it back to today, but not many, I think. And if you have any concerns about that, you can let me know. But some of you like really, I think it's a confusion or misunderstanding of the cash flow. Some of you use the 50K, it grows for 6 years, and then discounted back to not discounted back, to like use this one as the NOI to calculate the perpetuity divided by 6%. So rather than using 100K, some of you just assume the 50K will grow for 6 years, and this is wrong because it's stated very clearly at the beginning. The cash flow in year 6 is going to be 100K, and that is the perpetuity part. The 50K is only for the starting years that the occupancy is relatively low. It's the annuity part. And in question 3, you're concerned that the market might change in 5 or 6 years. So you want to increase the cap rate by 0.5%. So this is actually exactly the same as the previous question 2. It's just saying, oh, how about you use cap rate? New cap rate equals to old cap rate plus 0.5%, which is 6.5%. And he's still asking for PV5, which is 100K divided by your new cap rate. It's equals to 100K divided by 6.5%. It's 1.538 million. It's almost the same, other than the new cap rate. The most difficult or challenging question is the 4th one. That's why I stated the cash flow at the very beginning. So he says, the question 4 says, given the estimate of discount rate R and the future value, suppose you are still using the old cap rate, which is 6%, what is the fair value of the development today? So the fair value includes 2 parts. Total fair value includes value of annuity plus value of perpetuity. So we need to do it step by step. First, let's get the annuity, PV2. PV2 is because the annuity starts from year 3 and it will end in year 5. So by applying the annuity formula, you are actually getting the value of the cash flows 1 year ahead, which is at year 2. This is 50K divided by 7%, because you got the discount rate from first question, and this is discount rate, not the cap rate. Not equal, times 1 minus 1 over 1 plus 7% to the power of 3. So this 3 is the total years of annuity. And this 7% is R. So I want to emphasize again, R is never equivalent to cap rate. I saw many of you plug in 6% in the PV2 calculation. This is not right, because 6% is cap rate, is not the discount rate. So now you get the present value at year 2, and you get present value at year 5, which should be what we already calculated from the second question, is 100K divided by the old cap rate, which is 100K divided by 6%. I will not calculate the exact number, so you can check what it is. And some of you just sum together and report this number to me. It's really very close to the perfect, very close to the right answer. But to make it perfect, you should discount your present value at year 2 and present value at year 5 back to today. So PV, total PV at year 0 is, you need to discount PV2 to today plus PV5 also discounted to today. And what you will get is 1.3, around 1.3 million. So this is the right way to solve this question. And still keep it in mind, to sum cash flow together, you have to be very specific about which cash flow which year the present value is at. And before adding them up, you have to discount everything to the same time point. And the last question is a little bit tricky. So the last question does not change the annuity part. So your PV2 should be exactly the same as previous one. What changes is the PV5. PV5 now is 100K divided by new cap rate, which is 100K divided by 6.5%. This is also what we did in question 3. And I think that's the reason why he asked you to do it in question 3. Because here he's asking how much will the value increase or decrease if you use a more conservative cap rate of 6% for year 6 onwards. So 2 hints, cap rate itself already assuming this new number only applies to the perpetuity part. If you use this number to the annuity part, that's not right, because it has nothing to do with the annuity part. The second hint is for year 6 onward, it also hints you that 6.5% should be used for the perpetuity part that starts from year 6. And let's do the same thing as before. Will be still PV2 discounted it 7%. 7% back to today plus PV5 new, this is new one, discounted back to today. Altogether, we'll get 1.212 million. This is smaller than the 1.3 million. It's because your using a more conservative cap rate, which drives down your present value of the perpetuity part in year 5 and also in today. So because this part is changed, you will get this part changed. So once again, here you always use the 7% as the discount rate. Don't use the 6.5% to the annuity part or to this discounting back to today part. So because the discount rate R is not the same as this new cap rate, it's different story. That's all I want to say. And do you still have any further questions?
I just have a question. Just going back to one of like the last lines, like the last line for the first part of question 4, the last round we did. Where it says total PV, is that subscript? Is that present value of year 6 or 5? I wasn't.
You mean question 3, small question 4?
Yeah.
So the total PV includes both the present value, PV2 and PV5.
Okay. Yeah. So was that just total PV for year 6?
No. So from year 6 and ongoing, it's all about the perpetuity. So everything is summed up in PV5, and PV2 only contains the 3 years, the annuity part. So the total value today includes both the year 6 and the future, and from year 3 to year 5. Does it make sense?
Oh, okay. Yeah. Okay. All right. I just wanted to make sure on that.
Yeah.
All right. Thank you very much.
No problem.